All right, so on Friday, we began section 2.8 talking about rewriting equations and formulas, and we were introduced to this idea of what is a literal equation. So just a reminder that a literal equation is an equation in which letters are used to replace the coefficients and constants of another equation. Now, as we saw from the two examples that we did on Friday, sometimes you're going to have literal equations that have nothing other than variables in them. And so the first example that we worked out on Friday said we have ax plus b is equal to c, and we were asked in this particular problem to go ahead and solve for x. All right, so if we're solving for a particular variable, remember that our process is number one, combine like terms. Number two, get variables on the same side. Well, there's a lot of variables in this particular problem, but there are none of them that are alike. Number three would be to get rid of any addition and subtraction. So that's why we started in example 1a by subtracting b from both sides. If we subtract b from both sides, that gave us a times x is equal to c minus b. And then we knew that we had to undo this multiplication, which we can do with division. So we divide each side by a. Now make sure again that when we do this, that your fraction bar includes the entire difference of c minus b. We want this entire expression to be divided by a. Again, this is an advantage of making sure that we use a fraction bar instead of a division symbol. So we'd have x equals c minus b over a. That's our final answer from Friday. Now, in example 1b, in this particular problem, because everything was being divided by b over here on the right-hand side, our first step was to go ahead and multiply both sides by b. So when we multiplied both sides by b, that gave us b times c, and on the other side, that multiplication and division canceled each other out, and we had x plus a. Then we're going to go ahead and undo our addition with subtraction, so we subtract an a from both sides, and we have that b times c minus a is equal to x. And again, this equation has been solved for x, so that is our final answer. Now, I also would like to give you another variation of how to do this problem, not to confuse you, but to give you options for what you can think about solving for a variable. So again, if I were to take a look at the same equation, c equals x plus a over b. One thing that you can do, and you'll find this helpful later on down the road, so that's why I want to show it to you now. One thing that you can do is you can actually change this now into a proportion. Okay, which is what we just got done working on solving last week. How can I change this into a proportion? Well, we're going to do that by changing c into a fraction. So when I want to change c into a fraction, we're going to go ahead and just put that over 1, because c over 1 should still be equal to c. Now, I should be able to solve this proportion by using cross multiplication. My first cross product is going to be b times c. And my second cross product is 1, and then times the quantity of x plus a. Remember, we would technically have to have our x plus a in parentheses because we want this entire expression to be multiplied by this denominator. Now, my b times c stays as b times c. On my other side, if I went ahead and distributed it out, this would still just be an x plus a. So you're going to notice that by doing this cross multiplication problem, we're actually at the exact same step that we had right over here. B times C equals x plus a. Undo your addition with subtraction, so subtract a from the right, which means we're going to subtract a from the left as well, and we're going to be left with b times c minus a is equal to x. Now, you might not say that this is any easier than what we did before, and I'd probably agree with you in that case, but the only reason I want to show this is if the variable we were solving for would be on the bottom of the fraction, this would be a great resource to be able to get out of the bottom of the fraction. So just remember that you can still change these into proportions and then use that as a cross multiplication problem to solve. All right, let's move on though to our new stuff today, example 2a, 2b, and then the back page of this. So example 2a, you're going to notice that number one, we are no longer have just variables left in this problem. We now have numbers in here as well, but we are just given the variables of x and y. Okay, I'll be honest, most people find out that when you throw numbers back into this, there's a little bit more level of difficulty because now we also have to worry about reducing our fractions. Whereas up here, our fractions were reduced because they were just variables. Now, biggest thing is write this so that y is a function of x. Here's what I'm going to tell you. This set of directions ultimately is telling you solve for y. Anytime that they ask you to write an equation, so y is a function of x, it is always going to be asking you to solve that equation for y. So let's take that equation, 9x minus 4y is equal to 8, and we're going to go ahead and solve this equation for y. We're going to begin by getting rid of our 9x, and since it's a positive 9x in this problem, we're going to have to start by subtracting 9x. So if we subtract 9x from both sides, that's going to leave us with a negative 4y equals negative 9x plus 8. As we saw last year in pre-algebra, we always like to put our variable part first and our constant second. That's why I reordered this particular problem here. Now we need to undo your multiplication, and we can undo multiplication with division, so we're going to go ahead and divide each side by negative 4. Now, this is where we're going to need to do some simplifying. Okay, we didn't have to worry about it before. We do now. So pay special attention to this part of the problem. First of all, negative 4 divided by negative 4, that gives us a positive 1. So we have 1y over here on the left-hand side. On the right-hand side, both of these terms are being divided by negative 4. So first of all, take a look at your negative 9x and negative 4. Now, 9 and 4 do not have any common factors, so the numbers themselves can't be reduced. But a negative divided by a negative can be reduced, so this should become a positive. So we're going to begin this with 9/4 x. That's how that first part is going to simplify. Then we need to look at simplifying the second part of it. Okay, in this case, I'm taking 8 and I'm dividing by negative 4. So when I take 8 and divide by negative 4, that leaves me with negative 2. So my final answer should be y equals 9/4 x minus 2. All right, at this point, if you'd like to, pause the video, go through and work through example 2b, and then once you're done with that, unpause it, and I'll have this worked out for you here in just a second. Our first step in 2b is going to be starting to get this variable y by itself. So we're going to begin by subtracting 2 from both sides. Okay? Unlike in the previous problem, I actually can do some combining like terms here. So that's going to leave me with 6y on the left. And on the right-hand side, we're going to be left with 3x. But then this is going to be a plus 2 here because my 4 minus 2 are both constants. Those can both be combined together. Then we're going to undo our multiplication with division. So we're going to divide by 6. And over here again, we're going to divide by 6. Now, on the left-hand side, 6y divided by 6 is just 1y. But on the right-hand side, again, we're going to have to do some reducing. So if I look at my 3x and 6, I should be able to divide those each by a factor of 3. So when I do that, that's going to give me 1/2 x as that first part. And then when I go to reduce the second part of this, 2 and 6, both can be divided by a factor of 2. So when I divide that by a factor of 2, this is going to leave me with a fraction of 1/3. So we now have the equation y equals 1/2 x plus 1/3 as a final answer. I will tell you that when we get to these problems on your assessment on Wednesday, we are expecting these to not just be solved for y, but also to be reduced on the other side as well. Got to make sure we know how to reduce our equations as we go here. All right, let's go ahead and flip it over to the back then and take a look at examples 3, 4, and 5 to finish up today's lesson. So in problem number 3, the formula for the volume of a rectangular prism is V equals L times W times H. Solve the formula for L. Remember that a formula is an equation that relates two or more quantities with one another. In this particular problem, we're relating four quantities: the volume, the length, the width, and the height. So if I have this equation, V equals L times W times H, and we're looking to solve this for L. So we first of all have to ask ourselves, what's the operation happening to L? In this case, it's being multiplied. So we know that we can undo multiplication with division. Now, here's where we can do some cool things. You don't have to divide by only one thing at a time. So if L is being multiplied by W and H, and you want to get rid of that, you can divide by W and H at the same time on both sides. So when we do that, my left-hand side cannot be simplified. So this is going to be V over W times H equals, but on the right-hand side, my W terms are going to cancel each other out. My H terms are going to cancel each other out. And I am left just with the variable of L, which is the variable they asked us to solve for L, so that's it. This actually can be done simply as a one-step equation problem. All right, now number 4 is a little different because number 4's got a fraction in it. All right, and so I'm going to talk about how I deal with fractions here and hopefully give you a good understanding of what we're asking you to be able to do. So in example number 4, the area, which we call A, of a triangle is given by the formula A equals 1/2 B times H, where B is the base and H is the height. So the first thing it asks for us here is to solve the formula for the base. Right now, it is solved for A. We would like to solve this for B. So we're going to begin with our formula. A equals 1/2 base times height. Now, I know what some of you are saying. Well, just like in the previous problem, if B is being multiplied by 1/2 and H, let's just divide by those and be done. Well, here's the problem. We don't want to divide by a fraction, okay? So the first thing that I'm going to do in this example is I'm going to get rid of this fraction so we don't have to worry about it anymore. Now remember, this is being multiplied by B times H. So technically we could divide by 1/2, but we know that that's not good. What we'd rather do is multiply both sides by the reciprocal of this, and the reciprocal of 2, or of 1/2, is 2. So now, on the left-hand side, I'd have 2A, and on the right-hand side, my 1/2 times 2 cancel each other out, and I'm left with just B times H. So now we were able to get rid of the fraction, and we got rid of it without dividing by a fraction. Next thing we're going to do then is get rid of our multiplication. Again, we're asking you to solve for B. So we need to get rid of multiplication, which we do with division. So we're going to go ahead and divide each side by H. So when we divide each side by H, my H's on this side are going to cancel each other out. And I'm going to have 2 times A over H is equal to B. This equation is now solved for the variable of B. That's what they asked us to do, so that's our final answer. Now, in part B, it says, use your rewritten formula to find the base of your triangle, knowing the area is 106.8, and we also can see from the diagram that we have a height of 12. So if I already know my area and I already know my height, this formula right here says this is how you're going to find the base. So the base in example 4B is going to equal 2 times the area of the triangle, which was 106.8. And then we're going to divide that by H, which in this triangle happens to be 12. Now, this is an order of operations problem, so we're going to have to begin by multiplying before we do our division. So we'd have B is equal to, this should turn out to be 213.6. And then we're going to finish by dividing that by 12. Okay. So if I divide that number by 12, it turns out that the base is equal to 17.8. Okay, and I am going to talk a little bit about labels. So since all of these were in terms of inches, then our base should also be in terms of inches in this problem. All right, so there's example number 4. Example number 5. I'll let you read this, and then I'll come back through and talk about what we need to be able to solve here. All right, so this formula, A equals P times the quantity 1 plus RT, is actually a formula that we talked about last year. Okay, they're asking us to rearrange this equation, which right now is solved for A, and they would like us to solve this for R. So that's where we're going to begin this problem. So we have A equals P times 1 plus RT. Now, if you're solving this for R, you have options. Okay, you actually have a lot of options. You could, if you wanted to, divide each side by P to get rid of that, something that we've done already this year. Or you could, if you want to get rid of your parentheses, just go through and multiply everything by P. Okay? Your first step in that process is really going to dictate what type of answer you're going to look for. Okay? But realize that both of those would be possible steps for us. Okay? I'm going to go ahead and start with the distributor property because that's what a lot of us probably are more comfortable talking about. So, if we begin by distributing, we'd have P times 1, which is P, plus P times RT, which is PRT. Now, again, we're trying to solve this equation for the variable of R. So the next step that we would do is we'd need to get rid of this P that's being added here. So we can do that by subtracting a P from both sides. When we do that, we would have A minus P equals PRT. Then, just like in example number 3, we're looking to solve for R, and R is being multiplied by 2 things. So if it's being multiplied by those 2 things, we should be able to divide by those 2 things all at once. So let's divide each side by PT. And we're going to have A minus P over P times T equals R. Now, believe it or not, we could actually simplify this equation. We're just going to leave it like this, though. If you did solve this for R right away by dividing by P, I am going to put that answer in here. You could have A over P times T minus, this would be 1 over T. Okay? A little bit different looking, but it's actually the exact same answer as what we have down here. Now, the last thing it asked you to do is find the interest rate for 2 years. Again, we're going to use this equation right here. So they already gave you the A, they already gave you the P, and they already gave you the time as 2 years. Find R. So the account balance that we have is $682.50. From that, we're going to subtract the principal, how much we put in, which is a total of $650. And this is going to be divided by, again, the principal, which is 650, times the time in years, which in this case was 2 years. All of this should equal R. All right, let's go ahead and do our computations. Again, this is a grouping symbol. So we'll begin with our subtraction on the top, multiplication on the bottom. So we're going to get $32.50. And this is over 1,300. This is equal to R. So if we take 3250 and divide by 1,300, this R becomes 0.025. Now, if you recall when we talked about this formula last year, our rates must always be put into this decimal. So you should be able to take this decimal and convert it back into a percentage, slide this 2 spots to the right, and our final rate would be 2.5%. And again, 2.5% is the same as 0.025, the decimal that we got earlier. All right, so your notes should be complete. All right, for the rest of the hour, we're simply going to ask you to go ahead and work on your homework for tonight. And that is going to be page 129, numbers 5 through 25 odd. We will take a look at the homework and some additional examples and everything else for the next couple of days when I return. So good luck on the rest of your homework.